I don't know. We look at another teaching there. That's what I'm talking about. The whole process is people how do you teach it? How do you get it right? You may be a system and by the way,
Where you been?
Talking to Bill Farrell.
Federer's here? Is Federer coming in?
Bill Federer? I don't know. He walked away.
And we had adapters in the other room. See it? They had adapters in the other room.
See, I only have American ones. I actually broke the European in the plane. I had it plugged in, and then I put my footrest in and flew into the planes, man. The parts were flying. I didn't shortcut the bloody plane, so that was a good thing.
Yeah, you have a tendency to break airplanes. I think I don't want to fly with you anymore.
Good one, man. Yeah, good one.
What's more impressive is that guy that keelhauled twice. That's staggering. And the same thing, they told him, exactly how many seconds before he pushed the button. He followed the instruction and it saved his life. That's like, okay, I get it. I'll do it again.
Even if he made it up, which I don't think he did. The guy was like 50 decorated that, and he looked at
Those flyboys don't make shit up. They don't make shit up. They'll make shit up in a bar, right? And they're talking about their career.
So you have an adapter. It should be still fun. I should have that. So what do we need? We need blue sheets. Where are blue sheets? No blue sheets? What are the freaking blue sheets? And then we need the note, the jabber. You just want to show and that's like grown-up supervision. I will just step in once you start to digress into bodily harm.
So this is interesting. This thing is adapted, but it's not up here.
Oh, the mech thingy stuff over the fire thingy. Yeah.
Can you guys shut those other two doors back there so we'll get this? Just trying to keep the noise level down. Did you guys bring beer for everyone? Yeah, I'd survive with water. Oh, ice. I brought you two more of the double wit gin barrels. Yeah. Well, I brought one for you, one for someone else. So if we're gonna have the beer bottle share, since it didn't bring the room, I can't offer them. Welcome. You guys were Berlin. You're in the right place. I used that joke once already today. All right, welcome to the Beer Working Group. Hope you're in the right place. If you're not, you're gonna have fun anyway. So let's start. We got blue sheets. I think he's highlighted. They normally get filled out. They didn't get filled out this time.
Use slave is working already. Yeah.
Okay, we got the beer slave working. But before we move forward, we need someone to take minutes. We need a jabber scribe. You have a choice. You volunteer or you get volunteered. Who's never been to the Beer Working Group before? Also, maybe we see some vets here, huh? Are you volunteering?
Yes.
You're volunteering?
No.
No. You can't go forward, you can't have dinner. It's real mixed water. I'm driving to Steve. Okay, who's got blue sheets going on? We're going immediately, like, heads down and ask for a volunteer. I want to do it to you, Steve. All right, I know what you like to be after. So that means you're not leaving for beers after this. I'm not talking about leaving early. I didn't make sense.
No.
Good, we're all right, we're covered. Maybe we're following this.
Right. We can take us to good places.
All right, fair enough. Are you volunteering as the taking minutes today? Excellent, thank you very much. You've been volunteered. We're in the middle of a really in-depth conversation. You interrupted us, so now you've got to take minutes. How about a jabber scribe?
Yeah, we can foster creation.
Anyone on jabber right now? We got a jabber scribe. Volunteer in the back. Thank you. Young lady in the back is going to handle our jabber duties for us. See, that's what community service is all about. You guys understand what the working group? Excellent. You give me minutes, and I'll drop it on you. I appreciate it. All right, thank you very much. Look at that. I hate resorting to like the third grade teacher, like, demanding people to get their work done. I'm going to call your parents, I promise. All right, here's the note well. Well noted, everyone? Clear? Excellent. Can you keep it down in front? Can you keep it down? Sir, we're trying to have a meeting here. Can you keep it down? All right, thank you. All right, here's our agenda. I actually added a piece here I'll talk about in a second, but it's pretty clear. We've got only modification to this, I'll point out already, is that Torla sent out a request talking about the two concepts being split from the TE document. So FR stands on its own. He made it sound like he was requesting a time slot to present both, and apparently that's not the case. So we're just going to have the FRR portion presented today by Michael, and TE itself will not be presented independently. So other than that, anything else modified, adds, deletes, assaults? We're clear? Okay. What I did add to this was some discussion that went to the list about future NCAP. We've had several drafts being presented, some really interesting work, but in our charter, as it was pointed out, we're chartered to have MPLS NCAP, because remember, we're starting experimental here, right? Which the last thing we're going to do is boil the ocean. So MPLS was chartered, and one more NCAP, like in quotes, one more NCAP. So with that, I don't want to just burn that with the first new idea someone has. We should really be addressing the use cases, analyze the gaps, and then if we find their gaps, put together a design team who's volunteered to go after this work, and then solicit ideas and work from that work. So from Buenos Aires, we talked about potentially putting together an interim meeting in that direction. And it was really kind of a slow start. I couldn't get the right people to come to the table and make it happen. So I figure since we got room in the agenda today, and we got a good group of active participants, let's do that brainstorming now. Take the notes from there and then target direction. Make sense? Nods? All right. We got nods from the lady in the back. Did you see that? That was great. All right. Okay. Pardon me? Comments? You can take it to the mic. Name? All right. So the status. Let's see. We have drafts that we mentioned before that were like ready for last call. Some of these are on the edge of expiration, need refreshing. My concern, and we've talked about this, is that if we take the last call now, while the working group and the work is still an experimental, kind of get stuck there. And it was clear, I thought from, let's see, there it is. From the discussion we had in Buenos Aires, that from operators as well as from vendors, that they would like to see this work go to the standards track. But in order to do that, we have some hoops to jump through. We need real world deployment. We need some interop. And from that evaluation, we'll be able to make the determination whether this work can advance to the standards track. That being the case, I'm okay with holding these things in a holding pattern until that takes place. It gives us an opportunity to change things as we learn, and it gives us that opportunity to move all of this work as a body to the standards track. Comments? Here comes the troublemaker.
Oh, not in this working group.
Okay.
Alialis. Probably it'd be good to do a working group last call and even ask for routing directorate review on the drafts. You don't have to try and progress them out of the working group, but find and deal with all of the issues. Also, if you are thinking about wanting to get out of experimental, in the charter, as you, I'm sure, recall, they tried to write down a description for a document that would try and articulate and answer some of the questions. It'd be good to at least see a first stab of that to have a serious conversation.
Right. Even if there's plenty of open issues, at least we got a framework of a document that can address the pieces that we do have a handle on and then grow from there. Excellent feedback. Thank you very much. So what does it look like when a draft goes to last call, goes through the write-in area, but doesn't leave the working group?
It hangs out in the data tracker. It hangs out there.
Maintains its status in the data tracker, but it never goes to the queue.
Yeah.
Okay.
If you don't request public IESG publication.
Brilliant. That's why she's the boss. All right. Let's see. We have 4 new drafts were just adopted by the working group. Thank you guys very much. A little bit of a snafu there. I know you get a barrage of email, and I try to get you guys to respond that we're not just looking for, edits, updates, errors, corrections, whatever they may be, additions. When we're talking about adoption, it's like, yes, this is interesting work. So we got enough yeses. The first round was mostly authors, got that cleared up. We went through our 2 weeks, and now this is beneficial. I think one of you have already updated the ID on this for working group. So the other 3, please just update the ID. We'll move it in the tracker as a working group item, and our list of things to do grows. All right. And there we are. All right, so now on to the first agenda item. Which was that one, by the way? It was, BGP LS, Ran.
Good evening, everyone. I'm Zan from RT. Good evening, everyone. I'm Zan from ZTE. Today, I'd like to present BGP link state extensions for Bier. Next, please.
Can you hold
Okay.
on just a second?
Okay.
There's supposed to be a pink box on the ground. Make sure that you stand in the pink box so you can be seen. There's no pink box.
Makes people steal these days.
Oh, it's
Okay, hey, so someone's managing that. Yes.
Maybe the
No control? Wait a minute, there's something you can't do?
usually. No one's complaining on that.
All right, then you're fine. Assume this is the pink box. Perfect, right there.
Okay.
All right, next slide. I got that part.
Next, okay. About motivation, this document specifies extension to the BGP link state, address family order to advertising Bier specific. Next, please. Thank you. BGP LS extensions for Bier. We use the BGP LS prefix attribute TLV to carry the Bier information, and we also define a new prefix attribute TLV and a sub TLV for the encoding of Bier information. Next, please. Yeah. Now let's look at the detail of BGP LS extensions for Bier. A new prefix attribute TLV, which is called the Bier TLV, is defined for distributing Bier information. Subdomain ID, multi-topology ID, bit string length, BFR ID, and sub TLV are defined in this format. Next, please. Yeah. Right now, we only defined the Bier MPLS encapsulation sub TLV. This TLV is used to advance MPLS specific information used for Bier, and label range size, label range base, and bit string length are defined in this format. Next, please. Yeah, thank you. The next step, comments are welcome. And this is the second presentation for this draft. We'd like to ask for working group adoption. Yeah, thank you.
No comments or questions immediately? I see a show of hands who's read this draft. Leave your hands up. Those who think it should not be adopted, drop your hand. Okay, I have to do that, otherwise I can't do a count, right? Because not everyone's read it, and then I have to figure with the same people. And I've seen that. People say who haven't read it will then raise their hand for adoption, and that's kind of an odd thing. So it looks like we got some support from those who read it, which is good. So we'll have it in the minutes and take it to the working group, and we'll make a decision from there.
Okay, thank you.
Thank you very much. Okay, next is Vijanans.
Come on, you can do better.
Eisbrunnsvajans.
I sound like a German.
Pesh. Which one are you here? You are the, oh yeah, MLD.
Oh, really?
Why is it doing this? What did you send me? I'm gonna kill that one. I'm gonna kill that one. I'm gonna kill that one.
I'm gonna open this one. The heck is going on? All right, I've got, that goes away. View. There's no full screen option in this. I'm gonna kill it. Just quit. All right, cleaned up. Full screen. There it is. Way harder than it need to be.
Right.
But we're there. We made it.
Well done.
All right.
Well done. Okay, so I'm Ice from Cisco, and if you were in the PIM working group this morning, you already seen the slides, but we're sort of going back and forth between PIM and Bier for the time being. So I'll just run through the slides and then we'll have a discussion on where this belongs a little bit, afterwards. So this draft is about, let me start differently. So with Bier, we're adding a new multicast mechanism right into the network, which actually has the same requirements as PIM does, is that if you send it on a LAN, right, you don't want to end up with 2 forwarders on the LAN. So we're going to resolve that. Now, that problem is solved in PIM already, but it has, because PIM has a built-in mechanism to resolve DR election and DF election. But with Bier, we want to replace PIM, and also have a few different requirements when it comes to DF election. So don't necessarily want to depend on PIM actually to provide us DF election. It seems a bit weird that we would only deploy PIM just for that LAN-based DF election. So that's why we actually want to do something different. Next slide. So, and there's a little prior art already for this. When they went from version 1 to version 2 with IGMP, the query election mechanism was actually done in the overlay in PIM and I guess something else then at the time. You end up with multiple queryers on the LAN. They said, well, that doesn't really make sense, although IGMP is there anyway. Why does IGMP does not do the query election? I think DR and DF election is actually the same thing. So I think it's just historical why it was done in PIM, but I think it actually should have been done in IGMP. So that's actually, next slide. The proposal is to add DR DF election in IGMP, because that's the protocol that all the, let's say the tree building protocols sitting on top of that have in common. They all have to get the group membership information from IGMP. So it seems a natural place to resolve all the conflicts right there. Oh, by the way, I did present this already 2 IETFs ago, right? So I'm just giving an update here. Yeah, next slide. So in IGMP, so there is already this courier election, which we potentially could use for the FDR election, but it's not really robust, right? There's no times associated with it. There's no hold time. And you can actually run into a situation where you have 2 couriers at the same time, which today is not a problem, right? Nothing breaks if there are multiple couriers on the LAN, right? It's just additional control plane traffic you see, but nothing really breaks. So definitely don't want to depend on that, and we don't want to modify it, right? Because you have to change existing implementation, you get backwards compatibility issues, so you definitely don't want to do that. Also, by the way, DR and DF election is really the same thing. So if you are a DF, you are also the DR, right? So from now on, I will speak about DF election, but that also means you are the DR. Next slide. So here's actually some of the mechanisms that are added, for this version of the draft. So if we're going to do a DF election, we're going to make it group-based. So we do want to load share the DF election over multiple routers if they exist. Right? It's good for load sharing. It's also good for redundancy purposes. Now, the idea is this: we want to use the highest random weight as a function of the group and the candidate DF. If you have the highest weight, that means you become the DF for that group. Right? So this highest random weight mechanism is also used in different places, right? So EVPN uses that, right? We also use it for load balancing purposes, for ECMP logic, actually. So that's a common thing that is used all over the place. Now, this is really consistent, right? If every candidate DF has the same list. So if the routers on the LAN have the same list, this function produces the same result for everybody. So if we want to avoid any duplication and or loops, we want to make sure that the list is consistent among all the routers. So how do we make sure it's consistent? Next slide.
Well, can I ask a question there?
Yeah.
Do you feel this mechanism is the default or an option?
I think
The load splitting,
the load splitting, I would say that's well, yeah, it's default. I think it's
but it's not default today in
no, today it
PIM
doesn't.
election.
No, because it was never there for PIM.
Right.
And they're adding it now. They're adding procedures now and to make it an option.
Yeah, I think it would make sense as an option because there's going to be those networks where they want deterministic forwarding and not have to go look at the election mechanism at the edge. And if you don't have bandwidth to move all the traffic, with redundant routers, it's the load sharing may not be of value.
Right. Okay. That's good feedback.
No.
So since we're breaking up your presentation, the dot is a multiplication. It says 345.g on the formula. It's a multiplication, right?
Plus sign, just left in the middle plus sign.
Oh,
11035.
Dot G.
The way
not sure.
All right, back to math.
That's smarter people that can look at that. That's why I need co-authors.
Okay, and the second one is, so I don't know whether we talk about the same thing, but in EVPN we basically had people coming up and saying like, this is great, but I want a very specific router to take up the function. So we basically prefix the stuff with the weight, with the preference. Oh, okay, so we talked about it. Good.
Yeah,
You were napping.
we can do that.
No, I wasn't sure. You guys just had too much fun. So I think
Yeah. So first of all, to discover all the candidate DDFs, we add an hello mechanism, which is quite simple. So these hello mechanisms can carry attributes, right, and learn flags, for quickly to discover when you come up on the LAN first time. But I feel that creating this list that you do the highest random weight on, just based on this hello mechanisms, is not good enough. Because what happens if a hello is missed, right? Then you have the wrong list for the time being until the next periodic hello comes along, right? Or if neighbors time out, right? Timing out neighbors is not between different routers, can happen at any time, right? It's how granular your timer mechanism is and how close they are. But it's not. I don't feel that that's good enough. Next slide. So here's the proposal to actually allocate or choose a designated announcer. So based on the hello list that you have, now you have a list of potential neighbors. From that, you choose the designated announcer, and he compiles the list that everybody has to use, which is basically the list that you took from the IGP hellos, right? But it just comes from one place. And it's good if it comes from a single place, you make modifications to that, then everybody gets that modification at the same time, right? So adding and removing of entries from the list happens always from one place, which is a designated announcer. So that's a mechanism we enforce now to make sure that everybody operates on the same list. Also, since you know now who the 1 sec. No, stay there. I'll be quick. Since you know who the neighbors are, you can also do it reliably. So if you send out your new designated announcer list, right, and you know who should receive it, you can make it reliable by adding sequence numbers and acknowledgements. So if somebody would have dropped the hello, right, and the modification to the list, you can recover from that very quickly. Andrew.
Can you just go to the next one, just so I don't.
Name affiliation. We have no
Andrew
takers.
Dorgan on Nokia. Can you just go to the next slide, just to make sure that I didn't ask a question?
Next or a previous?
Next. Okay. When dial goes away, what happens?
Yeah. So the DEL is really just the highest IP address, the highest IP address neighbor. If it goes away, somebody else becomes the highest, and he just takes over. Unless, well, I think we had this discussion this morning. I think the gentleman over there asked that question. Do you want it to make sticky, let's say, and don't change? But it's, do you want it to be consistent, that you always say it's the highest one, or depending on who was the first, right?
And then you pretty much end up with the whole designated router election on SPF, which is actually significantly more complex than that, right?
Yeah. So maybe for now we'll stick with the highest IP address, and you can. But actually changing DAL from one to the other is not such a bad thing, because If the list doesn't change, then the DFs don't change. Stick.
Yeah, this is Stigmas. So we've been working on discussing this kind of stuff in PIM for years too, and one example too is, you know, when a router goes away, obviously some other routers will become the DR for that particular group and so on. And one of the questions, you know, is do you want things to be sticky there as well, right? If a router comes back up again, is it worth like readjusting, reshuffling the groups? Or is it better to, you know, whoever is forwarding right now to keep forwarding?
Yeah, we can do it either way, right? It's it's
one is easier to implement than the other. So it
Yeah.
depends whether it's worth it or not. But.
Oh, by the way, and also if you do detect inconsistency, which you can, right? Then we will choose to drops over duplication. Right? So you'll back off until it gets resolved, and then you continue to be a DF again. Yeah, next. So as you've probably seen in the draft, I haven't really added any packet types yet, but you know, I think it's better to first, you know, come to consensus on what the mechanism is, and packet types, you know, that will fall out of that quite naturally, which is not a big deal. No, well, that was more a note actually for the PIM working group. So this is currently a Bier working group document. Let's talk about that. Well, let's talk about it now. It's a Bier working group document because there's a problem that was raised within the Bier working group. Although the technology-wise, it fits more in the PIM working group. So we had this discussion already this morning on where it has to go. It is likely we'll do it in PIM, but we definitely want to make sure that, you know, we're very focused on this use case because Bier is the first use case for this. So we don't want to probably bolt on too many features here. But,
I'll give a status update, at least from the portion. We have the PIM chair here as well. So from today, we looked at this work and tried to parallel it with the other work that's going on in Bier. For example, we got IGP modifications, OSPF, and ISIS. And the decision from both those groups was to have the work take place here because the requirements were very specific to Bier. And we'll work closely with those other groups to ensure that, you know, we don't break the overall protocol, but it stays consistent with their architecture. In this case, this generic requirement for election is not specifically a Bier problem. It's really kind of historic that PIM was doing this and kind of, I mean, if I may say, an ego land grab that PIM is going to be the only mechanism behind the host interaction to forward packets. And things have changed since then. We've got MLDP and there's other mechanisms out there, but legacy has been PIM to do this election. Now, specifically for the Bier case, people have said, I want a PIM-free network. Yet we have to run PIM code to the edge just for the election when there really is no PIM forwarding taking place behind that. So the requirements are not uniquely Bier, but the immediate need has come from Bier. Now, that being said, ICE being the draft, the author of the draft, I think the only question about where there takes place in Bier, in Bier or in PIM is how can we make sure this stays on track and advances? So I would say that from the decision made today, let it stand on its own. Don't try to merge it with any other documents. Let it progress as is in PIM. And if for some reason we see things stall out or the, you know, other baggage starts to go on this draft that isn't immediately addressing this just isolation from PIM at the election, then we can have an interaction with the working group chairs together and the ADs and to make a decision to move it. Is that consistent with what we talked about today? Okay, I have nods from the AD in the back, which is great.
Yeah, I think that pretty much covers it. I understand your concerns, but yeah, I don't think that should be a problem.
Well, I think the difference is here is we don't see people from OSPF here at the Bier group, right?
Well, I think one of the unique things here is that well, one thing is, yeah, as you said, this is like very useful for other cases than Bier as well. And it is actually a problem we have been working on in PIM also. It's just that we always, you know, thought about we will have some PIM message, you know, and do like load balancing like this. And so the only difference in a way is the packet format almost. It is a problem we've been working on. But actually, what you have described here is very, very similar to a draft we already have, except it hasn't been published yet. We requested publishing it a few years ago.
But is this Similar in the mechanism, or you said similar using IGMP to do this MLD instead of PIM?
It's similar in the mechanism that
Okay.
things like having like one router that is selected to send out a list and
Right.
doing this kind of like hashing and all this stuff is already, been discussed.
Right.
So we have, in a way, I think we have even consensus in the working group for how a lot of these things should be done, which means that I think people also will support, a lot of what you have here because it's the same idea.
So
Okay.
Actually, let me put thoughts in your head, but it seems like what we're really trying to address with this draft is not improving the DRDF election overall, but taking PIM out of that process.
Well, you are improving it too, though, by doing this balancing and stuff.
Right. That's why I was wondering, like, was that default behavior or some additional functionality? And I'm a little concerned about adding more functionality to the process when what we're really trying to do is be consistent with the process, but without PIM. So I'm wondering if the draft maybe should just be thinned out to be just the IGMP messaging, and then any changes that come within the working group, there'll be an addendum to kind of document those changes to be done in IGMP as well.
That's possible, but I would say if people in this working group and also in PIM are happy with what you're proposing now, then you can hopefully move forward quickly with that.
Okay.
But I agree, there is a certain danger, people are like, oh, maybe we should support a different kind of hash, or maybe we want to allow some kind of like weighted thing, and there's lots of potential improvements.
But there's one important distinction here is that we want to use it for DF as well.
Yeah.
Right, and that's probably not the case.
Right.
With that draft.
Okay.
Yeah. So normally in PIM, it is the same router that acts both, as you can say, the first hop, DR or DF, and the last hop. But for the load balancing, we kind of specifically said we'll just do this for the last hop because we didn't have a need for doing it at the first hop.
But in that case, that's because the last hop is sending a join upstream. In the Bier environment, that wouldn't be the case.
Well,
yeah.
And with PIM, of course, the DF election is based on the reachability of the RP address, right, which is signaled back and forth.
No, well, I mean, in Bier with
in
DF,
Bier.
But in sparse mode, it's just
no. But in sparse mode, it's not a DF, right?
Yeah, but I mean, it is in a way though. It is who is responsible for forwarding packets onto the
RP.
Yeah.
Okay. Yeah, if you can send that draft to me, actually, then we can learn, right?
Either reference it in your draft, like the mechanism is done like foo, but in an IGMP message.
The less I have to put in this draft, the better.
But I would say the only difference between the two drafts is the robustness that you have here with the
the reliability.
Yeah, that's what I mean.
Okay.
And the other thing is that it's an IGMP message and not a PIN message. But otherwise, it's very similar. The other thing we should consider, I would say, is instead of improving the existing DR election in PIM, it's actually better to say, let's use this
PIM, use this.
PIM.
Yeah, that's a possibility.
And it could, in theory, be cases, where you have two routers on the same LAN. One has reachability upstream via PIM, and the other has Bier. Maybe that's weird, but it could happen. And then you want those routers to actually use the same election mechanism.
Okay.
Double checking. So do we foresee any interaction with the Bier overlay? Will the Bier overlay be completely unaware of the fact that the election is running underneath and pruning?
Pretty much. So we want to make this basically a generic mechanism, right? Which can host Bier, but potentially some other mechanism as well.
Yeah, understood. But will Bier overlay be affected by it by some means?
No.
No. Okay.
Does not.
Just double checking.
Yeah. Cool. Questions? Other comments?
All right. That's good.
Let me know if you got any feedback. If you want to help out, let me know. Thanks.
Thanks, guys. How can I not close this thing? Gosh, what a nightmare. All right. Next up is TE. Faster, you're out. What did that? All right, I'm getting tired of this. There we go.
So hello, my name is Michael Ment. I'm from the University of Tübingen in Germany. And I'd like to present this fast reroute extensions for Bier traffic engineering. It's a 0.0 version draft. Next slide, please. At the last meeting in Buenos Aires, the content of this fast reroute was integrated in the BRTE architecture draft, and there was the request to separate the architecture draft from the fast reroute. And that is what we've done in the meantime. So there is now a clean version for the architecture draft and the BRTE fast reroute methods. Next slide, please. Okay. About the Bier traffic engineering fast reroute. So what's the core idea? The core idea is that there is a Bier forwarding router component that that detects the failure and that initiates a local detour around the failure. So the allowed mechanisms are resetting bits in the Bier header, adding bits in the Bier header, and potentially tunneling the Bier packet. And all these mechanisms are independent of the actual multicast tree, which retains the scalability property of the Bier forwarding mechanism. When we talk about fast reroute, we need to differentiate between link protection and node protection. We can apply both. To explain you what this means, it's not difficult. I show you the next two slides. Next slide, please. Just ignore the text. On this picture, you see two multicast trees, one rooted in A and one rooted in B. And there is a failure between B and C. If this if this link fails and we want to have link protection, then the traffic needs to be detoured over the green backup path from B over A, D to C. In some cases, we need to reset some bits to avoid duplicate packets. Next slide, please. Go on, please, several times. Stop. Okay, what is node failure protection? Node failure protection means that a node may fail. So here you have the blue multicast tree that goes from the source S over N over F to D1. And now the node F fails. To protect this failure, node N1 needs to detect that F is not alive anymore, and then it needs to detour the traffic around that failure location over N2 to D1. That means the traffic is rerouted to the next hop within this multicast tree. This sounds like an operation that is multicast specific, but it's not. We can do a relatively simple operation based on the Bier header and the local topology information, so that so that traffic is forwarded to all relevant next hops. And these relevant next hops are those that receive traffic from the multicast tree over the failed node F. Okay, next slide, please. In the fast reroute draft, we have addressed three different methods for a fast reroute. And I'm going to explain you these three methods in principle. The first method is very simple because it just modifies the Bier header. That means what you see here is the Bier header on top, and what we apply is a reset bit mask and an add bit mask. We need to reset some bits. It's the red bit on the bottom that is reset because this is the failed adjacency. Possibly, we need to clear some other bits to avoid duplicate packets, and we need to add some packets for the for the backup path structure.
This modified Bier packet is just forwarded, and that makes sure that that the traffic is is forwarded to the next hop in case of link failure protection, and also to next hops in case of node failure protection. The drawback of this method is that we need to clear some extra bits on the backup path, and that may cause that some of the destinations in the multicast tree do not receive the traffic anymore. That means we want to save some destinations, and thereby we are killing others, and that is problematic. Therefore, we proposed tunneling as a workaround, because then the reset bit mask is not needed to avoid duplicate packets. Next slide, please. This is the second option. So here we work with tunnels that are provided by the routing underlay. So we assume that there is some tunnel that goes over a different path to the next hop and to all next hops, and we can leverage them in case of a failure. What do we need for this method? We need to have extra bits in the Bier header that stand for these tunnels, and we call them forward routed adjacencies. Those are the blue bits in the Bier header that you see here. That means the Bier header becomes longer. We need more adjacencies. And that is, of course, it may be problematic because we have more, we require more bits in the Bier header. Moreover, the routing underlay must provide these tunnels, and that adds also more state in the network. So also that may be problematic. And there is another problem with this approach, because in case of a node failure, it may be necessary to send several Bier packets to all the next hops individually. And if they all go over the same link, we may have multiplied the traffic in case of a failure over a single link, and that increases the load in case of node failures and node failure protection. Next slide, please. A solution to that may be Bier encapsulation. Why? With Bier encapsulation, we do not need use tunnels provided by the routing underlay, and therefore we do not need extra bits in the Bier header. Moreover, we do not need to. Moreover, we can send a single packet over a multicast tunnel with Bier encapsulation, so that in case of a node failure and node protection, we need to send only a single Bier packet over any link. And that's the advantage of method 3 over method 2. The disadvantage of this method is that we need an extra Bier header. If the bit space is very large, like 4096 bits, this may be prohibitive, but if the bit space is rather small, this may be a viable option. So in this case, what we need is on top, we have the original Bier header. This Bier header is encapsulated by another Bier header. In the outer Bier header, we have encoded the backup path, and in the inner header, there is the original Bier header, where just the bit for the failed adjacency is cleared. So this is Bier tunneling for fast reroute. Next slide, please. Currently, we are studying these different Bier traffic engineering fast reroute options. We are considering both link and node failure protection, and we are looking at different failure scenarios, like single link failures and single node failures. And we compared these options with live protection using Bier and multicast only fast reroute, where we have orthogonal multicast trees that are constructed with maximally redundant trees. The preliminary results are the following. Full coverage for BRTE cannot be achieved without tunnels. That means the first method I have explained, which is the very simple one, does more harm than good, because in case of a failure, we need to clear bits in the Bier header, and that results in traffic loss in other parts of the network. So actually, regions where without a failure, all of a sudden do not receive the traffic anymore. And that's certainly not acceptable. It may be not acceptable. The solution is simple, but it has its disadvantages. We investigated the hop length, and they are mostly lower for Bier traffic engineering than for multicast only fast reroute with multiple redundant trees. When we used unicast detour path, that means it's the second method, that causes high link loads when node protection is activated. And we found that Bier traffic engineering generally requires less capacity, considerably less capacity than 1+1 protection, which is clear because we have duplicated traffic in failure cases and also in failure-free cases. Okay, that's about it. Thanks.
Any questions, comments? Nods, approval? All right, thank you. So is the expectation this would be taken the working group as an adopted item? Is that the expectation?
I think so. Torres is right now not here, but well.
Because right now the architecture document itself has not been adopted, right? So that we got to get through that one first. So the fact it was pulled out was good.
The architecture one is more important.
Yeah. So I know there's been some discussion on that. We had a couple of outspoken people on the list who had some issues for Torless. I believe the authors, what I'd say, the authors believe they've addressed them, but we haven't heard feedback from those who put it out there. So if we can get some churn back on the list, kind of see where that draft is, see if we get some traction, and then because this won't progress without it, obviously, yeah. Right? So if you can chime in the list to get some feedback, hit me up to treat people like third graders again, I will. All right, thanks. Okay. And all right. Why is it doing this? See, but I don't want it like this. Okay, what is this document and why does it stay here forever? Right. Oh, here we go. View. That's what I want to get rid of. I get rid of this. And then this goes. Did it. All right. I'm going to shrink this a bit because I want to edit on the fly, if that's all right. Okay. Top of the hour. So I mentioned this a little bit. This came from kind of notes we banged around about how we'd go at this thing. So my intent is that let's have this discussion right now. We've had a lot of operators come to the room. I see 2 I recognize. Hopefully there's some more here. Because we in the original problem statement, and I think that all of you guys probably agree that the Bier work itself came from decades of pain. Right? Working with operators, working with real networks, working deployments and implementations and say, we got to do something different. And so we believe we've addressed those issues head on as articulated in the problem statement, and the feedback we've gotten from the operators has been fantastic. So with that, let's start by listing the MPLS use cases that we know we are addressing, and then any other use cases that we may be missing. And if there's some reason, some technical reason why MPLS encapsulation does not address those use cases. So now, this is going to be maybe a group's decision, but in many cases, as vendors, you've talked to operators, and as operators, you've worked in networks where people say, I'm not doing this. They can't give you a technical reason why They just don't want to do it, right? It's like, I'm not running MPLS in the shop, or, same thing, I'm not running PIM. I could say good reasons why not to do that. Or now even today, I'm not doing V4 anymore. I'm going pure V6. Some of these are technically motivated. Some are just, I'll call them religious motivations. But I want to try to keep the discussion around real use cases that technically can't be addressed with the existing architecture. All right, make sense? All right. There we go. First of all, I don't like that. It's got to be black. Didn't work. There it is. All right. Can someone free fall the mic with me, or I'll just nod? I mean, clearly MVPN is one that comes out right away, right? And I think that was pretty clear initially as a good common address. Any other particular use cases we think we're targeting specifically with this architecture in MPLS? EVPN. Anything else? I'd say specifically, like even if it's not an overlay, just PIM. I mean, there's an environment where we've got just a single PIM domain that's not Rosen MVPNs. What we have architecturally would address that directly, right? So just PIM deployments. I mean, just like feedback we've gotten was like, I want to get rid of PIM data center to desktop. We've heard those comments before. So anything missing from this? Any particular use cases? I mean, how about IPTV? Is that a use case I think we're addressing with this architecture? Right. So PIM deployment is kind of bright. I threw it out there, but if we need to, should we slice it up even finer grain?
I think your use cases you are driving with technology. Shouldn't be application.
Can you come to the mic just so we can all, it helps a note taker in the works too. But this is, we want this. We want some more than nods and hands today if we can do this.
Iftikhar, Infinera. As I'm saying, I think the listing, all of these are technology oriented rather, I'm thinking application. So should we go with the application, right? So like PIM, okay, this is protocol. I mean, rather than, okay, like IPTV, for example.
Yeah.
That way may be better, I think, use cases describing that way rather than a protocol.
So do you think MVPN and EVPN are use cases or technologies?
I think those are technologies.
But MVPN can be addressed in many different ways.
Exactly. I'm saying the point I'm trying to make is all these are technologies. So I'm saying is should.
Well, what I just said would counter that. Now, PIM deployments, definitely technology.
Yeah.
MVPN can be done with Rosen, can be done with MLDP, it can be done with you can build it like DMVPN. So it's a use case with various technical solutions.
Yeah, I think MVPN is VPN. It's a VPN. Okay, yeah.
How about EVPN?
Yeah. But it's, I mean, what are the services people and customer use? I'm saying is I think these are still look very protocol centric. I mean, okay.
I mean, is there anything particular like in enterprise network say I don't run it and I don't run MPLS? But what kind of the position we've taken is that MPLS encapsulation, MPLS forwarding or label-based forwarding for Bier is not LDP, right? They're not running a full MPLS infrastructure. They're just sharing labels in the IGP and doing hop-by-hop forwarding. Now, the trouble is you get an enterprise, I don't want to turn MPLS on, right? It's kind of a hard sell there, but there's no technical reason why label-based forwarding and MPLS encapsulation for Bier wouldn't work there. But that's maybe a better like use case. The other one that comes up, I'll throw it out here so we're not getting feedback. Data center. That's a case where we know there's multi-point services there that are challenged by the existing solutions. People can squint and say, Bier could be a great fit here. But we really haven't had anyone step up with a solution, or I should say, a solution that brings more to the table than what we currently have with MPLS encap. Because we talked to some data center customers said, I'm not running MPLS in my data center, and others saying, I'm putting labels from the host down. Go ahead.
Pierre Pfister from Cisco. I would like to support what you say. So I don't exactly know MPLS that well, so I don't know the MPLS use cases that you address with Bier. The point is that I'm working on data center use cases and some network use cases as well. And yeah, they don't have MPLS there. So you say it's not really technical enough. So if maybe there is a deployment issue first, management issue, if that's technical enough for you. Yeah. You don't want to manage MPLS if you can do everything with, in my particular case, IPv6. Like I don't want to have IPv4 in my network. I don't want to have MPLS in my network. I want all my packets to be IPv6 packet. I want all packets identical. That really helps monitoring, management, and more precisely, the use cases I see in my cases are in content delivery network family, like IPTV is one of them, but it could be like also types of content, not only live, and as well data replication in data centers. So yeah, in the very, I think we could potentially do everything with MPLS if we really wanted hard to have an MPLS network here, because in the end we do replication. But I don't know, as you said, people have reasons to not want MPLS.
I think you made up a good point. I mean, operational considerations is real. I mean, that's a real thing. And if they don't want to add one more thing to train people with, for lack of a better term, if they're standardizing on a V6 forwarding model and they want everything to be V6 across their network, right? They're going to look for a V6 solution whether we provide it to them or not. So that's a good point. Thank you.
Gregory Koshi, I'm missing one point on your slide. Your first question was what can't we address with MPLS? Then you started your list with what we can do. Then we are talking about what we can't do. So isn't, maybe it's just me, but isn't your slide should be like 2 columns with what we can, what we can't? So what we can continue on maybe the VPNs services, what I agree is maybe more services that we can do with MPLS, maybe broadcast IPTV, something we can do. And I agree also with what's been said just before, that if we want to have everything with IPv6 only, then MPLS is not maybe a good fit, or maybe there's a way to do so. I don't know, but just a form of for the discussion.
Yeah, if we keep on the same page, I think you're right. We can kind of look at it together rather than flipping pages back and forth. Other. So in the other case, I mean, we have that. I think. I mean, I don't want to push this out there, but there are operational considerations today, and this is really what happened in the last couple of years, where V6 is ramping up so much that people are trying to standardize on something, and that move from 4 to 6 is bringing with it that 6-centric kind of standard on the solution set, whether that's provider or data center or what have you. So, I mean, we could throw that out there. It's not necessarily a use case, but it is an operator consideration, right? An operator environment, maybe an operator, what we call that. You are co-chair here. Come on, you got to help out.
I have a slightly different perspective how I slice reality here, and one of them is it's a different way of thinking about it. I mean, will a new NCAPS improve the situation in deployment? Right? Will it make deployment easy? And I don't see a case. If we standardize a new Ether IEEE, it's a forklift, okay? If we encaps it into V6, I think the situation is actually drastically confused, because we're putting a 2.5 into a layer 3, so it looks like a point-to-point, local link address frame, and then inside we have the Bier stuff, which they still have to get to and analyze. So I see, Bier is a 2.5 forklift anyway. And the arguments I saw are pretty much religious, right? Like, I don't want this in my network, whatever this is. And it can go either way.
Pierre Pfister again. Maybe I'm just wrong, but I don't see Bier as a 2.5. I see Bier as a alternative to IP multicast, and I see IP multicast as a layer 3 thing. You talked about the deployments. Like I have an IPv6 only network. If I only have Bier in MPLS, I mean I really like Bier, really better than multicast. But if I have the choice between MPLS and IP multicast, even if it's the crappy multicast, I will use the crappy multicast NPM, not Bier, and I will be really sad because I would like to use Bier. I think it's better. I think Bier is better, but deploying MPLS, it's too much of a burden in these cases.
Go ahead. Go scream, Andrews. Shout. Go to the mic with ice. Duke it out. We want to see a celebrity death match here.
So ice, Cisco. I think we have to make a distinction, what MPLS we're talking about, right? Because MPLS, we're talking about encapsulation and very often also the control plane that comes with it, like LDP, RCPT, the label signaling that you use, right? So I think a lot of resistance against MPLS is also due to the control plane, right? And definitely with Bier, we don't have that, right? So we follow sort of the segment routing model where we just announce the labels in the IGP, which is quite simple. So we did get rid of the MPLS control plane. The only thing that's still left is if you look at the wire, there's like this 20-bit tag on the packet.
Right. And in fact, that could be an ether type, and operationally would be no different in your network.
Yeah. But then again, I guess with the very hardcore V6 people, they will say, if they look at the packet, said, hey, this is not a V6 packet anymore. Right.
And it's in config, right? It's in the configuration. People have to be trained to support it, understand how to debug it. So there is a layer there, whether it's not the full control plane or not. From a network architecture's perspective, they put the stake in the ground. It's hard to get past that.
Yeah, I just want to second that. So let's make sure that we're talking about MPLS as something on a packet. It will be there, even if we start. Okay, optimistically speaking, okay, V6, there will be something there. It's not that easy to switch everything to V6. So I think it's pretty much like I cannot think of a use case that we would make that we cannot do with Bier, or by introducing something. We can always introduce something. It's like, hey, keep ourselves reintroducing the same things, but I don't see how would that make things better, or other than just replace potentially a gear that's there and capable of doing all that stuff. I'm not talking chips, I'm not talking gear, I'm talking chips. With some other chips that may never be able to, although those chips are not there today, like most of them actually are capable to do everything. Yeah. So like I just don't see a use case. We had this discussion earlier about the Ethernet and caps, and like, but what were they bringing? That's different. What are they bringing? So maybe instead of us trying to, I would like to hear from people who don't want to have this label. What are they trying to achieve?
I think we got that from Pierre to some degree, right? Stig?
Yeah, this is Stig. So so we already have the Bier signaling, right? That basically says that this 20-bit value means a certain thing. That's all they're using MPLS for, is transporting that 20-bit value around. And you have an OSPF or whatever what those 20 bits mean. So one way of doing this, I mean, say like IPv6, all you need is to have a way of putting a 20-bit value or make it 32-bit or what you like into the IPv6 packet, right? And you could rely on the existing signaling for what that value actually means.
I just want to be very clear. We're not using MPLS. I know I do some MPLS, maybe not expert, but we're not using MPLS. We're using a place in a header, in a packet that has a specific format that we put a value in it. Saying that we're using MPLS is just so confusing to many.
Okay, bad on me. So basically what I'm trying to say though is all you're doing is you're finding a way of putting a 20-bit value in the packet. And even with a different encoding, you could still do that.
So I want to point out something too here. There's difference between encode and encap, right? With our label-based forwarding for Bier, we're not encoding anything in that label space. We just are encapsulating the packet with a label, and then there's a dedicated Bier header that sits behind it. That Bier header is nothing specific to MPLS. So, I mean, that's a question too. If we're doing a different encap, do we preserve that header? Or are we talking about trying to encode something into a different format? I mean, those are different discussions to consider as well.
So you are asking what can we add with a new encapsulation, and I'm proposing an encapsulation that would be based on IP. So one of the things it adds is the ability to send Bier packets between hosts, between servers within a data center. And I think this is to see what we can add, but I think it's not the only question. I would like to answer another question. What can we remove? You are sending IP packet over this MPLS encapsulation, I mean this encoding in a network. I'm just saying, let's get rid of MPLS. I mean, the question is not only what we can add, but what we can remove, and we can remove this encapsulation that is another protocol in front of the IP packet. I'm saying we can just get IP. And it makes things simpler.
So if this is a host stack, I mean, you could actually use the host to form any packet, right? You can put a label on it as well. I mean, that's a use case where if I could just be the stink in the room here. I mean, I've actually seen a presentation from a customer that was doing segment routing stacks at the host level in the data center. So, I mean, we're in that same thing again. I mean, I think we're gonna have a hard time coming up with a technical reason why you can or can't do one or the other, but there's definitely operational reasons for network design when people do or don't want to implement certain functions within their network.
Actually, just one point on that. Segment routing may be a good example. There is MPLS segment routing, there is IP segment routing as well. And our reason why they decided to do both.
Solid point. Thank you.
Xiaohu from Huawei. First, I think this is a good start to think about the possible shortages associated with the MPLS Bier handler. The possible shortage of the MPLS Bier handler is, since you use kind of indirection approach, it's be hard to do troubleshooting. In addition, there have been some discussion about the possible advantages of the MPLS Bier handler over generic Bier handler. So I think it may be better to end some analysis in this job to talk about real benefit using such an interaction approach instead of encode the information directly within the packet.
So tightly coupling the encode and the encap.
I mean, in current MPLS Bier encapsulation, it's used a label to indicate certain information which used for Bier forwarding, such as subdomain ID.
Yeah, primarily just to identify the packet as a Bier packet for the most part, right? There's no Bier forwarding information really in that.
Not just an indication of the Bier handler. It's also used to indicate a certain information, such as subdomain information.
Right, but let's not confuse that there's the Bier header and then there's the outer label. Right?
Outer label.
Okay.
The label. I mean, it's better to do some analysis about the real benefit using such interaction approach.
Well, I think that ship might have already sailed, right? That's moved forward in our charter. We're already doing that today.
Yeah.
The question is there a gap created by this that needs to be solved with a different set of tools? Right. So that's the analysis I'd prefer to see. Not analyze what we currently have. I think we've done that through our own due diligence and participation in the room you see right now. We've moved forward with that architecture. The question is, are there solutions, or excuse me, are there requirements out there that this solution is not meeting? And if so, what are they, and what do we need to do to address them? Now, I think to Pierre's point directly, it's probably a little unfortunate as an experimental group that we are wedged into this position right now. if we were a standards track and someone said, hey, I don't want to do labels, I want to do this in IP somehow, and we'd be open to it. And I'm saying we are too, but the trouble is we're allowed one extra end cap. Now we can recharter if we had to. If there's some reason tons of people came to it and they all wanted these various different solutions, we could probably recharter, and assuming we had the bodies to do the work. That's another consideration. People can throw out ideas and then they run. If they're not going to sit here and carry the flag to the end, well, you can't just put work on our laps. We don't even understand what your real use cases are, right? So, but if there's enough momentum of bodies and participants contributing to those solutions, we could probably recharter to bring out other solutions. Until then, we got a door for one more. And we want to focus on what's missing and how do we address that missing piece. That makes sense? So I'd rather do the analysis on what's missing than do the analysis on what we've already done, because I think we vetted that just by the fact that we're here today.
Okay.
Did I miss your point?
My understanding of the purpose of this job is to identify the possible shortages of the MPS Bier encapsulation, right?
No, actually, this isn't a draft. This is a working group discussion.
Yeah.
And the purpose is...
Will it form a draft later?
Potentially. If we see people who want to participate and a use case to attack,
yeah.
That's in the next piece here. It's exactly looking for volunteers who want to like maybe form a design team.
Okay.
Who bring all of their knowledge in. Like you got your dog in the fight and everyone's got it, but we got to come together and provide one solution for our open door for another end cap.
Okay.
Right. We can't do generic and V6 and VXLAN and dedicated ether type. Yeah, UDP. Right. There's a million different things we can do there, and we don't have the charter to do that.
Okay.
Our charter is MPLS and one more. So we're trying today to define, if we have that one more, make sure that one more actually goes right at the heart of a use case that we need to solve.
Okay. Okay. Thank you.
Gregory Koshi again. I have some troubles to make my mind right, because many things have been said and I clearly agree on many things. I may start first by giving my inputs as a former 15 years plus of ISP. There's a discussion about simplicity, and so when we talk about simplicity, we are looking at the face of the mountain where we are looking at. So if I'm an ISP, my simple way is to use MPLS, because that's what I have in my network. From my P to my PE, I'm using MPLS. So MPLS is the simple thing to do. Now, if I'm taking my new hat, which is more an ISP customer, so I'm more data center matters, all this kind of stuff, and I'm more looking from NIC to NIC, from VNIC to VNIC, so I'm more looking at V6. So this is more my simple way now than trying to add, which is also a good idea, to try to look at segment routing directly in bridges or V-switches or whatever. So I think the point of here is really interesting, is to, we've been discussing of segment routing on V6 and MPLS for good reasons, maybe not the place to have broadband, and I don't have all of them in my mind. But we've been also discussing Bier more or less after segment routing, because we were saying multicast is also interesting to have in a segment routing like, let's say. So maybe a good natural candidate is V6 at the end. Maybe there's no answer at the end of where does MPLS breaks. If we want to, we can put MPLS everywhere. And moreover, if we are not using the MPLS control plane, but just the forwarding plane, just the encoding of the stack. If there's no machinery, just a forwarding, well, we can do it in any software we want. So maybe there's no answer to where it breaks. It's if we have to choose one, and we have some needs, apparently many of us on IPv6. I'm sure everybody is not thinking about IPv4 or any EATM frame relay or whatever encoding we've been working with. So maybe the network and if it's experimental, there's no standard at the end. Well, we have it in mind, but it's not clearly the charter right now. Maybe these things is just natural at the end.
Yeah, that's a good point. I mean, I first of all, to your point, no one's going to address a V4 solution. Like, don't even bother. It may be just that where's our level of interest within the group, right? It's not necessarily a gap analysis on what solutions are what problem solutions aren't addressing, but more like, all right, where do we see the traction in the group where we see people willing to step up and make some progress here? But and your input was very clarifying. Thanks. You have different hats over long periods of time, and what's important to you changes with that. So we're not going to get one answer for the room necessarily. Go ahead.
So, Human with Golia, I'm from Nokia. I guess another perspective would be the mobile backhaul and EMBMS type of solutions. So we see a lot of operators that are beginning to start doing EMBMS on their network, Verizon Wireless, and so on and so on. So usually when it comes to the multicast services, MVPN and MPLS is the way to go in mobile backhaul. But there are some operators out there that they want to run multicast in the global routing table just without MPLS. And LTE and going forward to even 5G, IPv6 is a solution for some of those operators out there.
Gotcha.
From what I'm hearing from Bier point of view, since there's no PIM, simplicity in multicast protocols itself, so, that could be 5G and LTE in mobile backhaul could be one of the cases for IPv6 also.
Excellent. Good input. Thank you. Can I help you?
Always. Early Atlas. So a couple things. Maybe I haven't looked closely enough at the use cases, but for most of the use cases around MVPN or EVPN type things, obviously I think there is potential for Bier in the data center, but that's not an articulated case. I haven't seen the proposals or brainstorming around how one would do this with V6, but I assume you're talking still using the Bier forwarding table and the associated type of hardware changes. So
I would assume we're talking about what the packet looks like, not what the forwarding table structure looks like. I mean, I would hope that would not change. And in fact, if someone would propose like different fib structures and forwarding for different end caps, we would probably send them packing.
So I guess my point is we can call it V6, but it's not going to work on the current hardware, right? With Bier, whether you call it a V6 if it's an V6 encapsulation or not, you're still talking about understanding how to troubleshoot it and handle it. Now, if there are use cases, but to me, it seems like we're asking to do the work twice. And I mean, I'm not trying to say what the technical direction of the group should be, but it would be really nice if you actually finished your charter and didn't get too distracted. I know this is in the charter. I know the possibility of a second in-cap is in the charter, and I'm happy to discuss it, but I'm hearing, well, it might be nice in my data center, but we don't have clearly articulated the applicability. The V6 SR stuff has been its own amusement in terms of 6-man and trying to get those pieces progressed. You're still talking about changing all the hardware in your data center to handle it. MPLS, at least there's a fair amount of comprehension about how to do it. I'd really like to hear some fairly strong explanations.
I'm going to address those directly and stay at the mic because you might want to throw things at me, including the mic. So
No,
I'd say,
go for people.
first of all, Bier forwarding is, we know we've got IP, we got MPLS, and now we have Bier. I mean, that's the level we're talking about in changes. So we know there's going to be hardware revs in those boxes that can't do microcode. And my expectation is, again, like we mentioned, I articulated, it's different between encap and encode. And all we're talking about is on the wire, how do we tell the box that this is a Bier packet? And then how do we tell the box to then forward based on that Bier mask? So the mask has to come with that. That's it. Everything else below in the hardware should be part of the architecture going forward. So in the same way you change your addressing or something, or MPLS, and there's really nothing MPLS forwarding about this either, right? It's just telling the box with a label, this is a beer packet. Now, in terms of about distraction or finishing our charter, I think we are moving forward. We're making progress here. And the fact that people are coming to us with other ideas shows that we've got more fertile ground within the IETF coming forward. Now, if we want to continue to pile on the existing members more work, I'd say we're maybe getting derailed. But when more people are coming to the table with ideas and want to participate in our work, I don't think that is necessarily getting derailed, though, is it?
It's a perfectly fine discussion to have, and talking about a second encapsulation is in the charter, and I mean, obviously there's been discussion since the beginning about whether having a generic in-cap makes sense or not. Obviously, having more people interested, excited is good. Having more people involved and interested in contributing to the work, or deploying, is even better.
D what? How do you spell that?
Yes. But new working groups are always attractive nuisances. People always want to come in and add more things and do lots more stuff and think about cool ideas. You know this.
Sure.
One concern when we start looking in the data center space is it really V6? How are you doing your network virtualization? Is this stacking with something like VXLAN? What are the interactions there?
Personally, I would love to have not just one, maybe 3 data center experts involved in this, because everyone I talk to has their own soapbox and religion and know exactly how it's done. And the next guy's got a whole different set of discussions. So that's a very difficult one. And I'm not going to stand up and admit to be any level of expert, but I've learned enough not to listen to one expert and think he knows everything either. It's a really fragmented world.
Yes, different people with their data centers are doing very different things. And there hasn't been really good standardization in that space yet. And that's one of the problems. I'm a little reluctant to try and have this group dive into that morass as well. That's part of my concern.
And in terms of new working groups and attractive nuisance, I think we've gone through the majority of the great filter. If you look at the BOF we had in Hawaii, we filled that room with standing room only. And we kind of narrowed down a bit and swelled up. Maybe Berlin's a little easier place to get to than some others. But I think looking around, knowing these people, these are contributors right now. Yeah. It's not, I mean,
Greg,
there's
if I were
riffraff out
unhappy with how Bier was going, you would have heard it. I'm not shy.
I want to hear you come to the mic and actually say you don't like beer. Come on. No one's going to do that. Everyone loves beer.
I prefer mead personally, but.
How about a braggot? Can we settle on a braggot?
Bier has a lot of really cool ideas, and it's got a lot of excellent potential, and it's really nice to see it going so well.
Thanks. So what came out of the discussion too, and I guess the mic we had back was really, do we have a level of interest? I mean, it's not something we just take on without bodies who are going to tackle this. We've discussed having an interim where we focus just on this. And this is great because most of the time at the working group meetings, people present their work and, show of hands and we move on. And this is how the work needs to take place mostly. When we've got problems like this and people in the room, we can make some progress. So I can make a proposal rather than waiting till Seoul and doing this all over again. If we can focus on people who are willing to step up with work, maybe a list of drafts or get some ideas in draft form that we can discuss, and then have a focused design team look at those, consolidate to a single solution, and bring that back to the working group. Sound like reasonable? I heard a yep from a co-chair. All right.
I think after all this laugh feast, it is a forklift in any case, right? You may go behind the scenes and rename the draft eyes. But the question remains, I didn't see a strong show, like if that would be in caps differently, I would run that, and that's what I really want. So if 3 data center guys step up and say, we've write the draft because we want this bloody thing in, V6 link local to link local, put the rest behind it, we have a case. Otherwise, we have like mild preferences, prejudices, and thought.
We have a VX line draft, we have a generic and cap draft. I mean, there's stuff that's out there, hasn't been adopted, but discussions at least take place. So yeah, to my point, we've got VXLAN draft, we got a generic and cap draft. If there's someone with the intent of a V6 level solution, that needs to show up in draft form too, and then maybe those 3 get put together towards some commonality, whether we pick one or smash them together in some hybrid scary monster, I don't know, but that should be the work of the design team through a call for volunteers.
It would be good for those new drafts to actually have some architecture use cases behind it and not just technology, because technology is easy. Not to simplify it, it's easy to come up with technology to encode it differently, but like for those who create those drafts, if they can come, like we put a lot of effort in Bier up front to actually justify what we're doing and why we're doing it. Not because we could have done it, but from technology perspective, but because there was a need to do it. So I think it would help a group and would help me to see some real use cases to what we're trying to achieve and why, and take it from there. And people will be interested for sure to contribute.
So VXLAN has a very good justification what's being done, but it's actually not an NCAP. So
It's an encode.
No, you just do the VNI signaling.
Gotcha. Okay. Call for volunteers. All right. So that said, who would be willing to participate as part of a design team to tackle this area? All right, we've got a serious body count here. So let's do, I will take this call to the list so we can get some email names on it directly and encourage those with other NCAP or encode solutions to get drafts together and get them out into the list soon so that then we can have this information we can all read. We'll articulate these various drafts and then we can target a time to get in the same room with a whiteboard and throw things around. Sound good? All right. This has been great discussion. Thank you guys very much. This is, like I said, this is not often what we do in working group meetings, but this I find far more engaging, far more rewarding than just hitting the down arrow, which I normally do until my fingers numb. All right. Young lady in the back, want to give us some direction?
This is absolutely what working group meetings should be. This is a valuable use of working group time. It's excellent. Conversations. This is what we need. Thank you.
Thank you. Yes, bootstrapping a design team. We had plenty of participants here. We'll need to take it to the list anyway, right? So we can't just limit it to the people who can show up today. But this shows that we've got more than a critical mass of people willing to jump in and help out here. Thank you very much. Okay. All right, blue sheets. All right. Again, thank you. This has been very engaging and rewarding.
Just a logistical comment. Can we try not to schedule this with conflicts with like things like spring next time?
Yeah, sorry about that. They're listed, but then sometimes it breaks, right? Yeah, we did. We'd have to come Friday afternoon. Actually, before you guys run off, I would prefer if this interim meeting is a physical meeting and not a virtual meeting. So I know some of us have got visa issues for travel time and all that, and Seoul is not till November. So August is the next month, probably September make more sense. So end of August, September. I mean, is that a reasonable time frame for people who with their hands in the air? September? Yeah, because I think August is going to we're going to run into August in a heartbeat. Yeah, September is probably what we're targeting. All right. Thanks again. Have a great week.
If you on Friday afternoon, you're in the
There's nothing. Yeah, that kind of came out.
Nee, wir sind jetzt schon zu dritt hier, dementsprechend. Ich glaube, Wolfgang ist froh, dass er dann die Begründung